Michael reaction begins by forming an enolate. So dicarbonyls, one that have two alpha H's between the two carbonyls, are extra acidic because of the extra resonance you get once the enolate is formed. So these are great reactants for making an enolate and common for the Michael reaction. All right, so with that first step, we get a minus on the alpha carbon, forming an enolate. Now, the Michael is right here. I'm going to tip the alpha beta unsaturated carbonyl component on its side. And if we look at the alpha beta unsaturated electrophile, here go the arrows. So from the enolate to the beta carbon, and then the beta carbon already has 4 bonds to it. So if we bring in 2 more electrons, I need to move some electrons away. So the double bond swings to be between alpha and the carbonyl carbon. And then I have to finish out the movement of electrons by moving off of the carbonyl and onto the O. So what those arrows do is they connect the alpha carbon of the enolate to the beta carbon of the electrophile. And then if we come all the way over here, okay, so what we get from those arrows, draw everything in the enolate in the same spot, connection to the beta, then alpha. Alpha has a double bond to the formerly carbonyl carbon, which has the electrons pushed out onto oxygen. Now you can grab an H directly and form the enol and then draw tautomerization. But under these conditions, you can also bypass that step and just take the O minus, dump the electrons back to reform the carbonyl, and then I need to move electrons away. And so what happens is I have water around from my original deprotonation. Now I can take these double bond electrons, stop sharing here, grabbing a proton. Okay, what that does is it protonates the alpha carbon in this section of the molecule. And that gets us to the Michael product, where here is the part of the compound that formed the enolate, connection to the beta carbon of the electrophile, then the alpha, then the carbonyl, and this guy had the aromatic ring as well. We put in our tags. This is beta, and here's alpha.